Good afternoon, everyone. Let's just have another moment for everyone to join in. Welcome to the start of our seminar series, Strategic Water and Climate Actions within Planetary Boundaries. My name is Peter Wisnowski, and I'm really glad to have your role in this nice afternoon, morning, evening, wherever you are. All right, let us begin. First of all, warm welcome to water experts at Stockholm World Water Week and delegates that gathered here from all over the globe to join us at this very important session, Planetary Boundaries, Water's Central Role in Sustaining 10 Billion People by 2050. My name is Peter Wisnowski. I'm a World Water Week Young Scientific Program Committee member and PhD candidate at Stockholm Resilience Center, Stockholm University. And I am honored to moderate this exciting and very topical session today. First of all, let's think about what's the first word that comes to your mind when you hear about planetary boundary for fresh water. We know that fresh water is a bloodstream of the planet, a crucial resource of a sustainable future for 10 billion people by 2050. And as we navigate climate change and unprecedented resource pressures, strategic water actions must remain within their planet-safe operating space. So it's just a warm-up and an icebreaker. If everyone can just use your cameras and join the Mentimeter poll and think, what's the first word that comes to your mind when you think, okay, what is this planetary boundary for fresh water? Let's have a look. Right, we have too much availability limits. Inbuilt environment, absolutely. Yes, we have to have a transformative shift in water management, and it should be crucial because simply meeting current demands through incremental improvements will not suffice. We need to rethink how industries, cities, and societies use and protect water. Limits is now the leader. Scarcity, absolutely. And we need to provide clean drinking water for 10 billion people by the middle of the century. And besides water for industry and agricultural use, and let alone ecosystem demands. So we have to have more attention to all other sources we see there, inbuilt environment and pressures, absolutely. Now we have the wastewater and other alternative and early overlooked water sources that we are now looking at now. Absolutely. Thank you everyone for joining and sharing. And I think will be a great transition now to our first speaker, Langvang Erlandsen, a researcher at the Stockholm Resilience Center, and she'll be talking about focusing on the interactions between land, water, and climate and their role in socio-ecological resilience. She leads international projects on global water resilience, also forest-based climate solutions and Earth system assessments. And she'll be talking about fresh water outside the planetary safe zone and what can be done to bring it back from the brink. Please, Lan, the floor is yours.
Thank you so much, Peter, for that nice introduction, and hello, everyone. So in my talk, I will share with you how we came to the conclusion that the water cycle on Earth is now so perturbed that it can be considered to have left a planetary safe zone, and why it is of paramount importance to bring it back to safety. Next, please. Let's first have a look at the deep history in Earth. When we look at that, we see that the current relatively stable climate that we are enjoying is in fact extraordinary. For the past millions of years, it's been either too hot, too cold, or too variable, and only now in the Holocene, the past 12,000 years or so, has the climate been so stable that it formed the sweet spot that is ideal for civilizations to thrive, but that now is threatened by widespread human pressure. The question is, how resilient is the Earth system? How capable is the Earth system in retaining these conditions that human civilizations evidently need. Next, please. So 1.5 decades ago, Professor Johan Rockström with colleagues introduced the Planetary Boundaries framework in an attempt to demarcate a safe operating space for humanity. The framework identified 9 Earth system processes that are absolutely fundamental for maintaining these Holocene-like conditions by mediating the energy, water circulation, and nutrient cycle that support life and that life supports. Some of these boundaries are related to extraction. So biosphere integrity, land system change, and freshwater change are subject to extraction from human pressures. Others are related to waste, so climate change, ocean acidification related to greenhouse gas emissions, novel entities, stratospheric ozone depletion, atmospheric aerosol loading related to chemical pollution, and biogeochemical flows related to nitrogen and phosphorus input to the Earth system. Next, please. So freshwater as a bloodstream of the biosphere is, of course, an important part of the Earth system and a part of the Planetary Boundaries framework. Next, please. It plays a very complicated role in sustaining the Earth system processes. Next, water transport, nutrient, and carbon. Next, please. It transports nutrient and carbon. It regulates its cycles. Next, and it supports photosynthesis, support habitats and life forms on land and in water. And 1/4 of greenhouse gas emissions greenhouse gas emissions are taken up by land systems, which are possible only because of the presence of water. And in addition, water is also directly responsible for the formation of clouds and regulating how much of the sun's energy is blocked or reaches this Earth's surface. And it's also in itself an energy flow that regulates temperature, wind, and the weather patterns that we experience every day. Next. In our latest scientific assessment, we found that freshwater planetary boundary is to be the sixth boundary to be transgressed. This is with regard to green water, the water in soil that support all life on land, and the blue water in streams, in lakes, in ground that support aquatic systems and irrigation. Next, please. The freshwater change planetary boundary is not the only water boundary, though. Phosphorus and nitrogen are associated with the biogeochemical flows, leads to eutrophication. PFAS, microplastics in our water bodies are related to the novel entities boundary, and aquatic life associated with the biosphere integrity is among the most threatened. Next, please. And other boundaries, such as climate change, land system change, and atmospheric aerosol loading, are key drivers of changes in hydroclimate that pushes the freshwater outside its safe zone. Next, please. So as a consequence of these multiple pressures, blue water, here represented by stream flow, we found have exceeded the boundary already in the early 1900s and continue to grow. Next, please. This is well in line with findings such as that 1/4 of the global large rivers, less than 1/4 of large rivers globally remain free-flowing. Next, in Europe alone, there is 1 million barriers in rivers. Next, please. And the exponential loss of wetland also occurred for the past century. Around half of global wetlands degradation happened since 1950s, corresponding to around 7 times the greenhouse gas emissions coming from the global energy sector in 1 year. Next, please. In terms of green water, the upward trend also much reflects that of blue water. Next, please. And this reflects our observations of increased permafrost thaw, drought and fire, and waterlogging. So both a wetting and a drying. Next, please. The green water transgression is particularly concerning from the Earth system perspective because it plays an important role also for the land carbon sink. So for example, while tropical forests have so far acted as a net sink, absorbing our greenhouse gas emissions, drought as a key driver is now turning these forests into net sinks. In the Amazon forest, this might happen already over the next decade, amplifying the feedback to climate change. Next, please. Transgression in biogeochemical flows is also large due to the growing application and input of nitrogen and phosphorus to land systems, which enters our water bodies and contribute to the release of highly potent greenhouse gas, nitrous oxide, hundreds of times more potent than CO2 over a 100 years time span. Next, please. The transgression in novel entities reflect a global increase in various chemicals that largely are released to the environment without adequate safety assessment, especially with regard to system impact. Next, please. The circulation of water means that life, as well as humans, literally are bathing in this chemical produce that are increasing. Richard Carson, who led the fight to ban DDT in the 60s, famously stated that man is a part of nature and that his war against nature is inevitably a war against himself. And this still holds true. And we're not just now starting to see the effects of persistent organic compounds, microplastics, and the full mixed cocktail effect are still remain to be unraveled and understood. Next, please. But these continued transgressions are by no means a physical law. These curves can be bent and have been bent before. Ozone depletion, for example, is now within a planetary safe zone, much thanks to the Montreal Protocol. And Brazilian deforestation is ticking downwards every time there's political will to do something about it. And even for greenhouse gas emissions, even though we're still far from our 1.5-degree goal, it has in fact been bent compared to if no climate policies have been taken. Next, please. And it's not just wishful thinking. State-of-the-art model simulations show that bending the curve on terrestrial boundary is possible, but it requires a U-turn in both demand and supply side policies. Next, please. This include an urgent need to halve greenhouse gas emissions, revitalize ecosystems, practice sustainable agriculture, and monitor and manage sectoral contributions to boundary transgressions. Next, please. So as I now come to a close of my talk, I would like to share my reflection on the fact that the water we use is of the same age of our solar system, and a substantial part of that even older than that, originating from interstellar stars that came to our planet. While the water on other planets in the solar system either evaporated and evaded to the outer space, the Earth hold on to this water and keeps turning it around, thanks giving life and also now moved by life. Next, please. And it's only now in this tiny blink in Earth's history that a living organism is knowingly and consciously modifying the flows and compositions of the water. Next, please. So with the water now outside the planetary safe zone, the best of our science suggests that the fate of humanity is now increasingly interwoven with our ability to protect its flows. Thank you.
Thank you, Lan. Thank you very much for this amazing overview of where we are, where the planet is now, where the boundary is set. And for everyone who wants to ask some questions to Lan, we will have time after the first block, and we'll have also Q&A after. So please post your questions in the box, Q&A box in the chat, and we will get back to them in a moment. Thank you again, Lan, and really appreciate this overview. And now we're moving on to our next speaker, and I think that it's a great transition here because how are these changes visible and how we can actually get hold of them, how we can see them and visualize them. And here we have Jay Famiglietti, hydrologist and global futures professor at Arizona State University, where he directs science for the Arizona Water Innovation Initiative. And he previously led Canada's Global Institute for Water Security and served in NASA JPL's senior water scientist and advised California's state water boards. And he's going to talk us about rapidly changing freshwater availability as viewed from space. Over to you, Jay. Thank you.
Thank you very much. Can you hear me okay? Next slide, please. So I want to spend my time this afternoon here in Stockholm talking about a recent paper. Here's the title: Unprecedented Continental Drying, Shrinking Freshwater Availability, and Implications for Sea Level Rise. This is a paper that's freely available. Science Advances came out on July 25th. This paper will also form the first chapter of an upcoming World Bank report on global water monitoring that will be released later this fall. Next slide, please. So as an overview, I'd like to talk about the satellites that we use, the NASA GRACE and GRACE follow-on missions, then the three main parts of the paper: the continental drying, the freshwater availability, and the sea level rise, and then finish up with the need for some global indicators. Next slide, please. The GRACE and GRACE follow-on, next slide, please. The GRACE and GRACE follow-on missions, the GRACE mission stands for Gravity Recovery and Climate Experiment. It's NASA and the German Space Agency, launched in 2002, really conceived to measure Earth's time variable gravity field with unprecedented accuracy. The connection to water is that as water moves around the planet in the global water cycle, it actually impacts the small variations in Earth's gravity field. We call those the time variable part of the gravity field. And as these two satellites orbit around the Earth, they orbit over the poles, and as they encounter regions that have gained or lost water mass, they are pulled down towards the Earth or move a little bit away from the Earth in response to the additional gravity. The measurements were to primarily be used to estimate ice sheet mass changes and ocean mass changes that contribute to sea level rise. And a little bit of hope back then in 2002 that they would contribute to understanding terrestrial water storage variations on the land, and that's turned out to be actually work quite well. Next slide, please. So GRACE was launched in 2002. The follow-on, basically a carbon copy mission, launched in 2008. I mentioned how it sort of works like a scale, but the two satellites move up and down in response to mass changes on the ground. It measures the change on land, the change in the total water storage, not the absolute amount, but the change. Total water storage being soil moisture, surface water, snow, and groundwater. Time scales are monthly and longer, and regions now are down to about 25 square kilometers. Next slide, please. Next slide. So first part of the paper, continental drying. This map that we see here is a map of trends of changing water availability, changing total freshwater storage over the last couple of decades. The blues are gaining water, the reds are losing water. Last time we published a map like this, in 2018, there's much more blue at high latitudes gaining water and much more blue at low latitudes gaining water. And now we see a lot more red, especially at high latitudes. Also, the red hotspots for things like glacier melt and groundwater depletion, these darker red spots you see on the map, were more distinct, and there might have been more blue or less red between them, and now they've kind of all joined together. And so that's how we identified these mega drying regions in northern Canada, in northern Russia, in southwestern North America, and across the Middle East, North Africa, and across Eurasia. It's not that the other places are not drying, it's just that these are the ones that have changed the most and sort of linked together compared to our last paper. Next slide, please. So what's happening? We're looking at here the trends in the dry areas getting drier, the wet areas getting wetter. The wet areas getting wetter are shown in blue, the dry areas getting drier. That should be a negative trend, but we multiplied it by -1, so you could compare and see that the dry areas are getting drier, the wet areas are getting wetter, but the dry areas are getting drier faster than the wet areas are getting wetter. Next slide. We can look by area as well. The upper part of this rather messy slide, it shows the areas that are, how the dry areas are expanding. That's the red upward trend. And complementing that, then how the wet areas are shrinking. And on the bottom, that's looking at the extreme drying, and we see that extremes of drying took off really around 2014 and started a big upward swing, as did the extremes of wetting. But in both cases, the drying is worse than the wetting. Next slide, please. So overall, we see that continental drying, this desertification, is expanding by roughly 2 times the area of California each year. The trends are robust. They're associated with geographic features like glaciers and permafrost thaw and aquifer depletion, and are unlikely to change, at least without human intervention. Next slide, please. Next, okay, the shrinking freshwater availability part. Next slide, please. If we take that trend map and we map it to a template of the world's countries, we see that there is not a lot of blue. Much of it is in Africa. And we see that something like 101 countries have been losing water over the last 2 decades. Next slide, please. Let's skip over this one and then focus on this next one, which is another way to look at the data. These are the world's great aquifer systems. When we first published this map in 2015 in Sasha Ritchie's Water Resources research paper, we showed that over half of the world's major aquifers were being depleted, and they are continuing along these trends. So again, without any intervention, it would be difficult to bend the curve. Next slide. So 75% of the population lives in the 101 countries that have lost water over the last 20 years. The losses are, in fact, amplified by groundwater depletion in the world's arid and semi-arid regions. Next slide, please. Okay, so sea level rise. Next. When we look at where all that water is going, it's ending up in the ocean. The blue line here that's trending upwards is ocean mass increase over the last 22 years. And that is being fueled by the melting of Antarctica, which is the orange line, the melting of Greenland, which is the pink line, and the drying, the continental drying, which is shown in green. You can see now that that green line is falling below both of the ice sheets. And so that's for the first time that's been happening. Next slide. When we look at the trends of how what's happening, so same slide, but just looking at the bar chart of the trends. So we see the ocean mass increasing on the left, and then the contributions of Antarctica and Greenland. We see that the land terrestrial water storage is greater. We take that terrestrial water storage signal, and over on the right, we split it up into the drying regions, the glaciated regions, the alpine and regions and ice caps, and the places that are getting wetter. If we look over at the first bar there of the non-glaciated NGIC dry, we see that most of that loss is coming from groundwater, 68%. Next slide. The continents now contribute more fresh water to sea level rise than either of the ice sheets, and drying regions now contribute more to sea level rise than land, glaciers, and ice caps. And that's the first time that's been reported. Next slide. Okay, so the need for indicators, just a couple more slides. Next slide, please. Global water cycle and water availability indicators are sorely needed, especially in a UN FCCC Rio Convention framework, but they're nearly impossible to compile from ground-based data alone. We really need satellite science-based observations because they offer consistent means to meet these needs globally and by region or by country, as I showed in one of those trend maps. Final slide. The GRACE and GRACE follow-on satellites offer the potential for holistic, globally consistent data sets for calculating key water cycle indicators. And just to connect to the previous talk, we need to keep track of these things so we can try to bend those curves, as Wang Erlandson pointed out. Thank you.
Thank you very much, Jay, for this presentation and for this amazing outlook and the capacity of the novel technologies to see the change and also spotlight both on a global level and also downscale and see these differences up to a regional and local level. I think it's extremely important these days to have these opportunities for navigating this freshwater availability changes around the world. Thank you. And now we have a short Q&A for the first part, which is more on the theory and overlook of the freshwater availability. I would like you, Jay and Len, to turn on your cameras. So we have just a few words, if you may. First of all, a question to you, Lan. There is one wondering. We keep saying that water is essential for climate action, but in practice, why is the water industry still treated as an afterthought compared to energy or carbon? What would actually break that cycle?
Why is the water sector treated as a, yes, that's a good question. Possibly because there just hasn't been as much of the water sector, especially with regard to pollution, also takes place in places where there is not sufficient sanitation. So in developing countries. So this is not exactly my area of expertise, but my hunch, if I may speculate, would be partly because of that. That the lack of sanitation, the lack of pollution control, are much of that is taking place unmonitored industrial pollution. A lot of that is taking place in countries that are lacking monitoring and lacking facilities, whereas the energy sector are most of the greenhouse gas emissions come from richer countries. But that's a hunch. Maybe others have better inputs.
Thank you, Lan. That's I think it's a very insightful observation, and I think we're actually going to hear more during the second part. And a quick one to Jay. Do you think that people, not only the general public, but national and world leaders, are aware of the situation that you are observing, of these trends that you're observing?
No, I don't think so at all. I think we have a tremendous amount of work to do. I think that a few nations do, but for the most part, the results that we showed today are new. I think there's a lot going on in the world today. It's difficult to focus on any one thing, and water sometimes often takes a back seat to carbon. So we have a lot of work to do to raise awareness because there's a lot of work to be done to prepare for this future.
Yeah, thank you for this observation, Jay. And absolutely, I think I agree with you here. We need to raise this awareness, and it's one of the reasons why this year, the World Water Week, we have Planetary Boundaries as one of the key features. And with this being said, let's move on to our second half of the session, and we gladly welcome Magdalena Rzeszkowska, and she's a deputy chair of the Federation of Polish Entrepreneurs for European Affairs and director of its Brussels office, and she's a former Minister of Finance of Poland, and now leads Water Europe's expert group on water investment financing. And we're just going to present her pre-recorded presentation on socioeconomic investments in water. Let me just stop sharing the screen so you can take over.
Change makers. Ladies and gentlemen, colleagues and fellow change makers, it's an honor to be with you today at World Water Week, a global platform that continues to lead the dialogue on how we, as a global community, must respond to our most pressing challenges: climate change, environmental degradation, and the loss of biodiversity. I am here not only as a representative of the Water Europe Water and Finance Expert Group, but as someone deeply committed to embedding water resilience at the heart of our socioeconomic systems. We meet at a moment of urgency. Across the world, and certainly across Europe, we are living through what is no longer a future threat, but a present reality. Record-breaking droughts, rising floods, collapsing ecosystems. In 2022 alone, droughts in Europe caused damages of nearly 40 billion euro. The cost of water pollution across the continent runs into tens of billions annually. These are not numbers on a page. They are the lived experience of communities, industries, and ecosystems. Yet behind these challenges lies an unprecedented opportunity to reframe water not as a constraint, but as a catalyst for resilience and prosperity. Water is not only a basic human right, it is a strategic asset, one that underpins food security, energy systems, health, and industrial productivity. But today, water remains chronically undervalued in economic and financial decision-making. We must move away from seeing water as merely a compliance cost or infrastructure burden. Instead, it must be seen as a driver of climate adaptation, biodiversity restoration, and green competitiveness. This is the foundation of a water-smart economy, a system where the value of water is recognized across production models, investment strategies, and governance. It is a system where circularity is the norm, where we reuse and recover water, energy, and materials, and where adaptive, inclusive infrastructure anticipates shocks rather than reacts to crises. So, how do we unlock the investments to make this vision a reality? We know the public sector cannot do it alone. We must mobilize private capital at scale, but this will require us to address the structural barriers that have historically deterred investment in water systems. Long payback periods, regulatory fragmentation, low perceived returns, and above all, shared risks across users and sectors. But the solutions are within reach, and we are already charting the path. Let me share 6 strategic actions grounded in the work of the Water and Finance Expert Group and aligned with the European Water Resilience Strategy. The first action is to recognize and monetize water risk. Water risk is real and it is growing. From supply chain disruptions to regulatory fines, businesses are already feeling the effects. Yet many still fail to price this risk adequately. We need to internalize water risk in financial markets through corporate disclosures, sustainability reporting standards, and by tying investments decisions to science-based targets for freshwater. Water must be valued not just in cubic meters, but in terms of business continuity, productivity, and resilience. Second action is to make water resilience bankable. To attract investors, we must standardize and aggregate water projects. Many are simply too small or fragmented to scale. That's why we advocate for project bundling, technical assistance platforms through the EIB and EBRD, and the use of blended finance, combining public grants and guarantees with private equity. Blue bonds, sustainability-linked loans, and impact investing focused on measurable water outcomes shall become mainstream. The third is to drive innovation with stable demand. Europe is a global leader in water technology, holding over 40% of all patents. But too many solutions never reach commercial scale. Let's close the valley of death by aligning funding instruments like Horizon Europe and the Innovation Fund to support technologies from pilot to deployment. Public procurement must serve as a launchpad for innovation, and water as a service models can shift the paradigm, where users pay for outcomes rather than infrastructure. The fourth is to build a water-positive regulatory framework. Regulation isn't just a constraint, it can be a catalyst. Revised EU directives such as the Industrial Emissions Directive and the Water Reuse Regulation are powerful tools to create predictable demand. We need efficiency standards, reuse obligations for industrial clusters, and tax incentives for closed-loop systems. Predictability attracts investment. Clarity unlocks action. The fifth action is to mainstream water across EU finance and policy. Water resilience must be integrated across the EU sustainable finance framework and across public investment vehicles like InvestEU, LIFE, and the future MFF. We are calling for a dedicated water transition fund to de-risk high-impact projects and bridge the gap between public ambition and private capital. And finally, the sixth action, to foster basin-level collaboration and co-investment. Water does not respect borders, nor should our solutions. We propose the development of industrial water clusters, where users co-finance reuse infrastructure governed through transparent basin-level platforms with shared KPIs. The future of water resilience is relational, not siloed. Let's build on success stories from across Europe and scale what works. Colleagues, water is no longer a side issue. It is the issue at the intersection of climate, security, biodiversity, and prosperity. Socioeconomic investment in water is not a luxury, it is a necessity. It is how we future-proof our industries, regenerate our ecosystems, and protect our communities. Let us move from fragmented funding to holistic financial planning. Let us move from policy ambition to bankable project. And let us ensure that investing in water resilience becomes the rational, profitable, and urgent choice for every public and private actor across Europe and beyond. Thank you.
Thank you. Well, let's thank you, Magdalena, for this great and I think very on the spot presentation. And actually, to follow up on one of her key points, I would say that these solutions that we're building up at the national and supranational level should be localized, and they should be entrenched in the local actions. And our next speaker is going to tell us more about it. And please welcome Emily Woods. Emily is a CEO and co-founder of Sanivation, a local enterprise providing citywide sanitation solutions in East Africa. With 15 years of experience and over 40 projects across the sanitation value chain, she's leading expert in fecal sludge management and innovation. And today she's going to share us her story on circular water and wastewater solutions and sanitation services. The floor is yours, Emily.
Thanks, Peter. Happy to be here. So far, we've talked specifically about water, but also the challenges. I hope today to talk a little bit about some of the solutions we're trying, as mentioned, at local levels, at what's really working on the ground. I'm going to be speaking from here in Kenya, but I'm also very much going to be speaking about fecal sludge management, which fits in the water category, but maybe doesn't. And we said that the question earlier about why is water oftentimes left out of a priority. Well, if water's left out, sanitation, I feel like, is about 20 more levels down from the water discussion. So happy to be here and discuss it. As mentioned, my name's Emily. I'm the COO and co-founder of Sanivation, a private entity operating mainly here in Kenya. And you can go to the next slide. I'll speak a little bit about my company. So as mentioned, we're a private sector, and we're focused on partnering with the government to try to develop sustainable sanitation solutions. Specifically, we work with utilities here in Kenya. We design, we build, we implement and operate everything from master plans to waste collections to treatment plants. We reached to date for a few 100,000 people. We're actually active in 4 different countries. Kenya and beyond. We've created hundreds of jobs, and we're developing a pipeline of about $40 million of infrastructure sanitation projects. Today, I want to do one specific case study of a city here in Kenya. And if you go to the next slide, this is a beautiful beach here in Kenya. It's Malindi, Kenya, where I'm actually calling from today. Not everyone be jealous. It is just as beautiful as this looks. As you can imagine, it's home to some incredible tourism. There's marine parks, there's coral reefs and water sports. And the culture here, that the entire city is based on its interaction between water, beaches, coastal areas. And yet, next slide, only about 2 kilometers from this picture here is what is the city's land dump. This has both the municipal waste, but all of the human waste. This is it. This is the landfill and the only designated place for waste to go within 100 miles. And so exhauster trucks come here, as well as plenty of municipal waste. And most people have no idea that this is here. Go to the next slide. We've been working with the World Coral Reef Foundation to actually look at the impacts of human waste on coral reefs. And so this is a quick map of the East African coast, specifically here in Kenya where I am, where you can see the coral reefs in brown and the marine parks in yellow. And you can see the yellow dots of extremely high, raw, untreated human waste. And they've found that raw, untreated human waste is actually one of the largest degradators of coral reef here in the area, on top of all the other impacts that we've heard. Next slide. So what do we do as a private entity? We partner with the government. And back in 2020, we partnered with the utility here called Mowasco to develop a citywide inclusive sanitation plan. Basically, what is a 20-year plan to start trying to deal with this human waste? This plan includes toilet innovation and increase. It includes waste collection, but it very much puts a focus on the initial waste to value treatment plant. This was the top priority and where we started back in 2020. As we went into designing this, few thoughts come to mind is what scale does this work? What is the business model where this not only gets built, but actually operates? And even what are some of the climate impacts? So if you go to the next slide, we did lots of studies to understand not only what is the current population here in Malindi and the surrounding areas and what is currently being collected, but what does that look like over the next 15 years and how does that increase? For the financial piece, we designed a waste to value treatment plant where we're taking human waste, combining it with agriculture waste, and treating it and converting it into a sustainable solid fuel. That's a replacement for firewood. And if you click the next slide, most people don't consider about the potential carbon impacts when it comes to waste treatment plants. And in fact, there was a recent study in Kampala showed that over 50% of Kampala's greenhouse gases were caused by poor sanitation. And so in this treatment plant, we're looking at actually improving carbon impacts on two sides, both preventing methane release from waste anaerobically decaying, but also using waste to replace other products that normally require more carbon to produce, such as firewood. In fact, this plant actually saves about 150,000 tons of carbon dioxide being produced per year in its operations. Next slide. This is the plant that we designed. It's going to be serving over 100,000 people. It is that waste to value treatment plant. It's saving trees. It's having carbon impacts that I talked about. It's also creating jobs. So there's a lot of benefits in this treatment beyond just the waste treatment itself. Next slide. I'm really excited to say that we partnered with utility and actually helped them through a PPP, as we were just talking about, come up with a way to fund this plant. So it's World Bank funding combined with us as the private sector coming together to build this. It's in construction now, and it should be finished in the next year, which is really exciting. If you go to the next slide, and beyond just the treatment plant, we're looking at other impacts. And so the only way of collecting pit latrine waste here in Malindi is still by manual pit emptying. There are hundreds of people who do this illegally by night. And so if you go to the next slide, you can see some of the work that we're doing as well is that, again, taking a for-profit approach, we're partnering with these manual pit collectors to help them develop more improved but still financially viable business models using semi-mechanized pit emptying, as well as helping them develop as a CBO to be able to fight for their rights and to be able to fit within the policy and framework here in Malindi. And so those are just some examples, and I'm happy to take more questions on this, but really want to say that decisions last decades. And so by investing in solutions that handle that business model, if you go to the final slide, we really can impact the people, the planet, and our pocketbooks. So again, my name's Emily, one of the co-founders and CEO of Sanovation here in Kenya. And so happy to share with you a real life example of what's happening here in Africa. Thanks, Peter.
Fantastic. Thank you, Emily, for this inspiring case study on what can be done at a very local level in this beautiful place, and in contrast, also quite saddening photos, and how this all can be changed by, as you say, it's a long-term story, but best of luck with this. And I think here is one of the things that Emily mentioned is this connection between these local actions and working with the governments. But what are the governments doing on this topic, and what can be done on the nutrient and nutrient management and nitrogen management, for example, is one of the planetary boundaries that are breached now. And this is what Mihai Constantinescu is going to talk about. Mihai is UNEP Working Group on Nitrogen co-chair and also works in the Ministry of Environment and Waters and Forests of Romania as an institutional coordinator. And we gladly welcome Mihai to talk about nitrogen policy development within the UNEP working group on nitrogen. Over to you, Mihai.
Thank you, Peter. Good afternoon to everyone. I would like to start by saying a few words about the working group on nitrogen. So we are actually 97 member states here working together on the sustainable nitrogen management with two co-chairs nominated by the Committee of Permanent Representatives, myself and Ms. Purvajara Machandran from India. The working group was established through the decision of the UNEP Executive Director in 2022 and made operational since then with the support of the Secretariat. We are also having a website. Next slide and then next slide. Thank you. So why is important to talk about nitrogen? Why is important to have policies on nitrogen? Because nitrogen is invisible, it's everywhere, and it's cascading through the environment. So we do have water pollution because of nitrates, ammonium, which leads to eutrophication and groundwater pollution. We also having air pollution, NOxes and ammonia are air pollutants, and of course are falling down to water and soils. We are also experiencing loss of biodiversity, especially in oligotrophic habitats, and we do have nitrous oxide, which is one of the most powerful greenhouse gas. The impact in human health, soil degradation, and ozone is also well recognized. Next slide, please. Some nitrogen facts. At the level of the globe, there are 200 million tons of yearly wasted nitrogen. Considering that 1 kilogram of nitrogen in terms of fertilizers, it costs $1, then it means that we are losing roughly $200 billion per year. We also can recognize that half of the world population is alive due to nitrogen fertilizers, and of course we do have a Bosch reaction, getting ammonia from methane. And nevertheless, we do recognize at global level that reaching critical limits of a safe use for humanity are touched, and this is why we need to take action at the policy level. Unfortunately, there is no convention on nitrogen. We only have two international agreements: United Nations Environmental Assembly Resolution 416 and 5/2, which are not mandatory, are actually what the ministers for environment agreed to do at global level. Next slide, please. So what we done in the working group, as I said, with 97 member states, we prepare a roadmap for up to 2030, focusing on developing and implementing policies on sustainable nitrogen management at the global level. We discussed about this last year and this year at the beginning of July, and we consider the roadmap agreed. We are also having a national action plan template agreed since last year, and countries are beginning to prepare policies according to this guideline, I would say, because the main provision of the UNEA resolutions actually is to accelerate actions to significantly reduce nitrogen waste globally by 2030. We're also looking to provide support, scientific support for the member states, and to have more concrete policy guidelines for the member states. The working group also acts as a forum for the dissemination and communication of information, and this is what we do on daily basis. We are having the working group meetings, but also webinars, seminars on this, and looking further to have workshops, regional workshops. Next slide, please. So to conclude, our challenges in policy preparation remains raising awareness on nitrogen. Nitrogen is not that visible in terms of pollutant, of greenhouse gas, or a contributor to environmental, one of the environmental damager. Increasing access to fertilizers remains one of the purposes and agricultural production, so we don't have to affect this, but we do have to reduce the nitrogen waste. Ensuring knowledge and technology transfer, this is very much requested by developing countries, and we do believe that developed countries are having more things to do in this regard. And also we have to consider developing integrated policy, because currently most of the policies are either on nitrates, either on ammonia, either on nitrous oxide. Next slide, please. So having in mind that our main task is to encourage member states to adopt measures for the reduction of nitrogen waste, we are looking further to set up scientific support for the preparation of the national action plans. At least 13 countries already requested support in this regard. We are looking towards harmonizing indicators and monitoring systems, but of course, at the basis of everything are actually actions to be adopted by the member states. Deeper collaborations with various multilateral environmental agreements and organizations. We are also looking to do a bit more, and funds. I will end up with funds. We'll need more funds to put our actions in place. Thank you.
Wonderful. Thank you, Mihai, for sharing the status of this incredible work that you do internationally. And I think just to maybe follow up on this, we know there was actually recently published that nitrogen caused nature and health damage, costing the Dutch economy 14 billion euros per year. So this comes in handy, and actually I wonder if the Netherlands are part of this working group. I'm sure they are. Thank you very much again. And let's open up for the question and answer, and I welcome all the speakers to join me here. We have a few questions here from the chat. First one to Emily. Thank you for your very encouraging presentation. I'm curious, how are sanitation plans addressing emissions from on-site sanitation systems such as septic tanks? From my understanding of the Kampala study, the majority of greenhouse gas emissions are generated from on-site sanitation.
Yeah, it's a great question. Absolutely, the Kampala study.
All right, Emily, I think we might have lost Emily, but that's okay. We'll give her a moment to reconnect. I think another question.
Fantastic to, again, the sound cut out there for a second. And so with,
Emily, can you hear us?
Yes, sorry about that. I was saying that it's the data from that study is so helpful for just that purpose. Very much just talking about on-site sanitation, but it also specifically says one of the biggest causes is actually pit latrine waste that's breaking down. And so that has helped to restore that as a priority, is not only emptying pit latrines, but one of the biggest thoughts now is, okay, the frequency is that if we can actually empty pit latrines much faster, then we're able to prevent some of that methane reduction. The other thing as well is looking at new now toilet designs, such as like septic tanks are more anaerobic. You're allowed to you don't have that methane production. And so is there a way of also changing how pit latrines are done to be able to have less greenhouse impact as well? So definitely some things that we're looking into, and definitely more and more data that we have on this, the more it helps sets those priority and focus areas.
Thank you, Emily, for this insightful answer. Another question we have here, and I think I can address it just in general to the speakers. Maybe one of you can uh, get it. Do we have examples where the right human actions impact the global numbers in a positive way? So I think this question is about the connection between human actions and global numbers. Anything that comes to mind, or anything that we need to aspire for? Let's try maybe. I think it's something that you, Jay, were talking earlier.
So I don't need to, I can just speak. You can hear me okay? Okay. So actually what comes to mind is actually not that much in water, but I was just thinking about the Montreal Protocol and how we were able to really bend the curve back on the ozone hole and ozone emissions. And so, there's precedent there. When we want to act, we can act. I like to think a lot about what we might do in global groundwater. I think it's achievable. We're certainly making decisions to pump a certain amount, and we therefore can make decisions to pump less. So I'm optimistic about that.
Thank you, Jay. And I think Mihai has something to say. Mihai, please.
Thank you, Peter. Yes, I believe at the level of European Union, the Nitrates Directive, which is from 1991, had an impact on water quality. So eutrophication, yes, in the last 20 years, I think it's lower, and this is due to the prevention and reduction measure adopted by the member states at the level of EU.
Yes. Let's see if you manage to convince our audience with your answers. Because let's go to our next mentee. And on a scale on 1 to 5, how confident are you that humanity can stay within planetary boundaries by 2050? Please join the mentee and cast your vote, and we'll see what the audience thinks after the session. And I think it was a very fruitful one. We had a long discussion. I think we showed how serious the situation is right now, and also showed what local and regional actions can be done. So let's see if we have the confidence level ready. All right. We'll wait for a moment to get the final numbers. I think with the number 2.3, I mean, there is some optimism, right? But very cautious one. It's still, more people think they're less confident in that the planetary boundaries will be staying within the limits by the middle of this century. 2.3. I think this is our number now. And I think on this note, not a happy note, but it doesn't have to be a happy one. I think it just shows how important this conversation is, and how we need to maintain sharing and exchanging knowledge, but at the same time also working together on this complex issue. And in this final remarks, so we have a future seminar sessions tomorrow on actions on novel pollutants and preserving biodiversity within planetary boundaries for equitable water futures. And then on the 26th, on Tuesday, the same time, we have only in-person session on responding to risks of freshwater planetary boundary, strategic actions from global to local. And these sessions, we work closely together with our co-conveners, UNEP, GWWI, and GPNM, also IVL, the Swedish Environmental Research Institute, and also Water Europe and Rank Sales Group. And I thank all the co-conveners for bringing everyone together, and also thank you, amazing speakers, and I think very insightful, a very professional discussion we had today. And I want to wish all the participants a very happy and fruitful World Water Week, and we'll see you guys tomorrow. Thank you.